Here we talk about graphs of equation. The graph of an equation in two variables is a set of points x by y, x and y fit the equation. Here are two simple examples. Y equals constant. Well, that's an equation. And its graph consists of all points x by k. Y equals k. It's a horizontal line. X equals k, another very simple equation. Its graph is a set of points k by y. And that consists of a vertical line. Here we have an equation, y equals x, a pretty simple one. Now, okay, to graph this, it helps if you draw a table of values. So when x is 2, then so is y. When x is 1, y is 1. 0 by 0, 1 by -1 by -1, -2 by -2. These 5 points are on the graph of the equation. Here's -2 by -2, -1 by -1, 0 by 0, 1 by 1, and 2 by 2. Okay, these are only 5 points on what's a continuous infinity of points. But it's a good enough guess. You can see that they all lie along this diagonal line. So that's the graph, the diagonal line. Here's y equals x squared. Okay, and let's plot out 7 points. When x is 2, x squared is 4, 1 squared is 1, a half squared is a quarter, 0 squared is 0, minus a half squared is a quarter, minus 1 is 1, -2 squared is 4. And so, okay, you can plot those points. -2 by 4, -1 by 1, -a half by a quarter, 0 by 0, a half by a quarter, 1 by 1, and 2 by 4. These are only 7 points on a continuous infinity of points. But okay, your calculator will plot out hundreds of points and you can draw this graph. Sorry, it's a little I should rewrite this a bit. It's a little steeper on this side. This is a U-shaped graph called a parabola. You've actually seen it quite a few times. For example, it's the shape of the cable of a suspension bridge. Golden Gate Bridge has parabolic. It turned upside down. This would be parabola would be the arc of an object flying through the air under free fall. If you look at a flashlight, the mirror has a parabolic cross shape because this enables it to focus light into this parallel beam. Now, given a graph such as this, there may be various points where it meets the y-axis and points where it meets the x-axis. Where it meets the x-axis, these are called the x-intercepts. That's where y equals 0. It meets the y-axis at the y-intercept. That's where x equals 0. So, equation of a circle. Given a circle with center h by k and a radius r, it needs an equation. Well, okay, if you go through the distance formula, just say that if this point x by y has distance r from h by k, then it pretty much quickly follows that this equation follows. The square of x minus h plus the square of y minus k equals r squared. That's the equation of a circle with this center and this radius. Given a graph, it may have various symmetries. Here we have a graph which is symmetrical around the x-axis. If you flip the graph to the x-axis, you get the same graph. In this case, that means that if the x by y is on the graph, then x by -y is also on the graph. You have a graph symmetrical around the y-axis. If you flip to the y-axis, you get the same graph. Therefore, if x by y is on the graph, then -x by y is also on the graph. Here we have a graph of an equation, and the graph is symmetrical around the origin. So if you turn it around 180 degrees, the graph stays the same. This means that if x by y is on the graph, then -x by -y is also on the graph. So they have some examples. Graph y equals 1 minus x squared. Okay, there's some values. If x is 2, y is -3, 1 yields 0, 0 yields 1, -1 yields 0, and -2 yields -3. So here's 2 by -3, here's 1 by 0, here's 0 by 1, here's -1 by 0, here's -2 by -3. These are 5 points on a parabola, U-shape pointing downwards, like that. Here we have graph y equals x plus y squared equals 4. Well, it's simpler if you get right at one value in terms of the other. It's called a function. So x equals 4 minus y squared. So you can give various values of y, -3, -2, -1, 0, 1, 2, 3. You get various values of x, -5, 0, 3, 4, 3, 0, -5. So, okay, we can plot these points. Here's -3 by -5. Here's -2. Here's 0. Sorry, here's -5 by -3. Here's 0 by -2. Here's what happens, 3 by -1. Here's 4 by 0. Here's 3 by 1. Here's 0 by 2. And here's -5 by 3. And again, these are, you plot these, and these are 7 points along a U-shaped curve of the parabola, in this case, pointing to the left. Here we have for the center radius and graph of the graph of this equation. Well, we can write as x plus a root x minus a -3. So, and this 25 is a 5 squared. So this is the square of x minus -3 plus the square of y minus 4 equals 5 squared. Now going back to the equation, h and k are the center, r is the radius. So going back here, in this case, h is -3, k is 4, r is 5. So the center is -3 by 4 and the radius is 5. It looks something like this. Now here we go the other way around. Here given some geometric figure details, and we're told to find the equation. Let's find the equation of a circle with a diameter whose endpoints are -1 by 1 and 5 by 9. Now, if the diameter has those endpoints, then the midpoint will be the center of the circle. So let's find that. Okay, in the midpoint, you average the coordinates, -1 plus 5 over 2 here, 1 plus 9 over 2 here. After a small amount of arithmetic, it's 2 by 5 is the midpoint. Now for the radius, okay, you have some choices. You can take the distance between these two endpoint points and take half of that for the radius, or you can take a distance from -1 by 1 to 2 by 5, and that's the radius, or 5 by 9 to 2 by 5, and that's the radius. Either should, all three should do. Let's do 5 by 9 to 2 by 5. So square root of sum of squares of 5 minus 2 and 9 minus 5. Root of 9 minus 2 squared plus 9 minus 5 squared. After a bit of arithmetic, that's root 25 or 5. So the equation is x minus 2 plus y minus 5 squared plus y minus 5 squared equals 5 squared. Now here we're doing the other way around. Here we're given an equation. Find the circle that this is an equation of. X squared plus y squared minus 4x plus 10y plus 13 equals 0. Now, first thing we need to do is to shuffle all the x values together. X squared plus 4x. Here are the y values, y squared plus 10y, and move all the constant to the other side, -13. Now we're going to use a trick called completing the square. Z squared plus bz plus what equals what squared. Here's the trick. So we want to write a term here that completes this as a square. Okay, the trick is you take half of this b and square that. B squared over 4, write that there. And this b over 2 goes up here. So z squared plus bz plus b squared over 4 equals the square of z plus b over 2. All right, so here, take this -4, half of that is -2, square that is 4, add 4 to both sides to keep the equation balanced. Here's y squared plus 10y. Half of 10 is 5, square that is 25, add 25 to both sides. So on the right side, it's -13 plus 4 plus 25. On the right side, well, this is x minus 2 squared. And these three terms come out to y plus this 5 squared. So x minus 2 squared plus y minus 5, y plus 5 squared equals, this works out to 16 or 4 squared. So x minus 2 squared plus y minus a -5, that's plus 5 is minus a -5 squared, equals 4 squared. So here's an h, 2, here's a k, -5, here's an r, 4. Center is 2 by -5, the radius is 4. Here they ask, here are two equations denoting circles, and do they intersect? Okay, reading off the center, this denotes a circle whose center is 0 by 1 and whose radius is 2. This denotes a circle whose center is 5 by 14 and whose radius is the square root of 9 or 3. Okay, now you have to find the distance between these two centers, 0 by 2 and 5 by 14. And after a little bit of work, that's 13. These two are 13 units apart, but this only reaches out 2 units, and this only reaches out 3 units, and those add up to 5, which is less than 13. So these circles do not reach out far enough to intersect each other.